for this kind introduction. You actually saved me the first 3 slides. Today I'm presenting high-quality telephony using a fail-safe media relay setup. We are providing web services to our customers for more than over 10 years now. Mainly, in this time, we are focusing on relaying SIP packets only. RTP traffic has been bypassing our systems most of the time. These requirements changed recently, and we had to introduce media relays into our setup. In this talk, I will describe what challenges we've had in this time, how we've solved them, and how we've implemented a fail-safe media relay setup. So the plan is to proceed in the following order through this talk. First of all, I wanted to present one-on-one, but Daniel did this for me. Next, I will give an overview of the network infrastructure, how it has been in the past. Here, I will also mention the topic quality of service, which is a very, very important point when talking about real-time traffic and relaying RTP packets. Afterwards, we will progress to the central topic of this presentation, the media relay setup, and how we've extended our web architecture implementing or using SIP-wise RTP engine software. One of the biggest challenges we had in this time was to realize redundancy. Here I'll describe how we've done it using Redis database and the key space notification feature from Redis. In the end, I will give a short roundup and summarize the central points once more again. So one-on-one is mainly active in the 2 domains, applications and access. In the application domain, we are providing web-based services like email and web hosting products. This is completely out of focus today. We are focusing on the access domain, where we provide DSL access to our customers and our web service. We are quite a large company with more than 8,000 employees worldwide. As Daniel said, in the German market, we take the 2nd place when measured with or based on customer contracts. Here you see also some other numbers describing the company. I will not read all of them. You can find them also on our website. You can find us in the following places all over the world. But as said, we are focusing today on the VoIP service, which is only valid in Germany, or only provided for the German customers. The VoIP backend development mainly takes place here in Karlsruhe, where we have one of our data centers, and with great support from our colleagues from Bucharest in Romania. So talking about the VoIP services we provide in Germany, let's tell us some numbers we have. We have a lot of customers with 12 million registered numbers. They are generating a huge bunch of calls, and this is a real challenge for our backend. In order to provide a reliable service and to handle those requests reliably, we have a backend consisting of more than 100 servers separated into data centers which form a geo-redundant active setup. We also have SIP interconnections with our partners Versatel, QSC, Telefonica, and Vodafone. So let's take a high-level overview of our network infrastructure. Here we see the one-on-one IP core with the 2 data centers I just mentioned, one in Karlsruhe and one in Baden Airpark. We see also that one-on-one has no own access network. We are here cooperating with our partners which provide these services for us. Here are our customers. The main information out of this slide is notice the routing paths. The SIP traffic were transmitted via our network, whereas the RTP traffic took the direct end-to-end path. As mentioned in the beginning, when talking about RTP, quality of service plays a crucial role. And it is at this point I want to describe how it has been realized in this setup. So here we see how the access network. And I don't want to go into too much details here. The most important information is the separation of the voice channel on the subscriber line and the separation of of the data channel in the subscriber line, which is mapped to separate VLANs in the transport network. One of those channels, the voice channel, has been prioritized in the setup, whereas the other one was the packets transmitted in the other channel have been transmitted best effort. With a newer access technology, VDSL, the connection changed a little bit, and we lost one channel. So for voice and data, there has been just one channel. And our concept, how we've realized quality of service so far, could not be applied in this setup. So we were searching for a solution, and we talked to our carriers and asked them what we can do. Can they offer us quality of service in this case as well? And yes, they said they can, but we have to provide them a specific IP range from which and to which RTP packets will be received in a prioritized manner. And we couldn't provide this IP range with our current setup because we would have to give them all the IPs of our customers, but those is not a consisting IP range, and the IPs are too widespread. So for us, this was the time where we had to introduce media relays into our setup. Pretty early, it was clear that as well as with Kamailio, we also want here to go with an open source solution. So we started to evaluate the available open source solution, and the requirements we had upon the software were best met by Zipwise RTP engine product. So we started to get involved in the RTP engine project. And we have introduced this network component and this software into our platform, which changed or which evolved to this setup. Note here, we have now 2 additional data centers located in Frankfurt at the date 6. Why there? Because we wanted to the delay we introduced by this additional network component should be as low as possible. And in Frankfurt, all the carriers have interconnection points, so this was the best position for media relays in our case. And this is how the routing path changed. For ZIP, there has been no change. The only thing we've changed in our already present ZIP network infrastructure is to change the Kamailio configuration file so it invokes RTP engine software in the correct way. And you see that we now have control also over the RTP traffic. Nonetheless, the old path is still valid. We did a hard switchover, but instead we pushed customers step by step to the new architecture to gather experience. At this point in time, students tend to ask me, is this really worth the effort? I mean, this path is obviously longer than this one. But yes, it is worth the effort. This shows some benchmark calls measuring the speech delay between a VDSL subscriber line and the ESDN subscriber line. And this is the part where RTP packets have been transmitted end to end. This is the part where we used media relay with activated quality of service. And we can note 2 things. This curve shows the speech delay of both connections without parallel other traffic on the subscriber line. So without, for example, a parallel download. This one was the speech delay with a parallel download on the subscriber line. So basically, quality of service starts to play a role when there is a lot of traffic and the bandwidth starts to get full. And in this case, using media relays with quality of service shows a significant improvement. So same as with the SIP setup, let's continue with some performance numbers. Currently, we have 6 media relays active in our setup. They are spread in the 2 data centers and are running RTP engine software from Zipwise, which is controlled by Kamailio's RTP engine module. We have a full redundant active setup in place. So we are able, or we don't lose sessions if 1 or even 5 media relays out of the 6 media relays present will crash. The customer, those crashes will be transparent to the customer. How this is realized will be shown in the next slides. Currently, in peak times, one media relay handles up to 3,000 concurrent sessions. And in a worst case scenario, they would be even able to handle 18,000 concurrent sessions. In our test bed, we even succeeded to test successfully 25,000 concurrent sessions using just one media relay. During the tests, we faced some limiting factors. The first one was the bandwidth. In our first tests, we used 1 gigabit interfaces on the media relays for RTP relaying, and those went full pretty fast. So we started to use 10 gigabit interfaces on them. Next, we started to run out of sockets. So we've extended in parallel with Zipwise, which we found out, RTP engines, so it's supported multiple IP addresses at the same time. And last but not least, 18 million packets incoming and outgoing generate a lot of interrupts on your hardware. And we faced this as well, and we started to improve the interrupt handling on the machine. So what we did basically here was we are using 3 mechanisms. The Int'l flow directive on the network controller, as well as the IRQ call on the inter network controller. This one, the interrupt calling, does not much more than, instead of generating one interrupt for each incoming RTP packet, it waits until there are several packets received in a specific amount of time, and then generates one interrupt for all of them. The Int'l flow director, here you can control based on some characteristics, like for example destination port or source IP source port, that RTP packets belonging to the same session will be copied to the same queue in the memory. And this, together with configuring the APIC, so interrupts belonging to the same session will be mapped to the same core on a CPU. Those features together optimizes the utilization of the CPU cache and overall improves performance. So in the end, we end up with a session mapped one-to-one to one specific CPU core. So let's take a closer look at the setup we have in Frankfurt right now. We can see here the 2 data centers we have. And in each data center, 3 media relays are running. As said previously, each media relay has one 10 gigabit network interface configured, which is used for RTP relaying and maintaining BGP sessions, and 1 gigabit interface, which is used for communication with Kamailio and for communication with the Redis database. Currently, the Redis master database is only present in 1 data center, but we are planning to extend it here as well. Additionally, each media relay is running a Redis slave database, which receives replicated data from the master database. And the database, the Redis database and the BGP session plays a very important role, or a major role, in our redundancy setup. Because if something like without a redundancy setup, if a media relay crashes, you would lose the ongoing sessions on that media relay, and it would have direct impact on the customer, which suddenly will hear no audio. And this was not an option for us to go live with such a setup. We didn't want to have this. So we started to implement a redundancy setup, and I will describe how we've done this using Redis and Redis key space notifications. So here we see a simplified illustration of the setup with just 2 RTP engines, the Redis master database, each RTP engine having a slave running. And you also see here already, each RTP engine has 2 IPs configured. One is the default IP. This is the IP, if you are familiar to our RTP engine config, which is at the first place in the interface list. And the other one has also the two IPs configured, but here it's different. Here IP2 is the default one and the one used for relaying media. And also note that both media relays announce the IPs to the core router, but with different priorities. There is always, here, the route to IP1 here is the route with the highest priority, whereas here is the route with the highest priority is to IP2. The RTP engines are configured like this. RTP engine 1 is writing to the Redis master database into key space 1. Key spaces in Redis context are something like tables in MySQL, for example, or databases in MySQL. And RTP engine 1 is configured to listen locally on the local slave for notifications on key space 2. RTP engine 2 is configured vice versa. It is writing into the master database key space 2, but listening locally for notifications on key space 1. And here we have Kamailio, which controls both media relays. Also note that both media relays are active. So there is not an active one and a passive one doing nothing. Both are active, both are relaying media. Kamailio is talking to both of them. We will now go through a simple call scenario and see how this media relay setup and this redundancy feature works. So first of all, Kamailio will, when relaying or establishing a call, will contact here, in this example, RTP engine 1, which will establish a session using IP1 for relaying media. Next, RTP engine 1 will persist the session information to the Redis master database, and the Redis master database will replicate the information to the slaves, using key space 1 in this context. Now, the Redis database will generate notifications for this, because RTP engine 2 is configured to listen and handle the notifications for key space 1. It will handle the notification and create a session on IP1 here, which is announced as a low priority route and in normal operation mode not used. In this situation, both media relays are completely aware of the session and have the same session information and are able to relay the RTP packets. So what happens when there is a hardware error, for example, on RTP engine 1? Eventually, the core router will discover this crash by missing BGP keep alives and will just withdraw the announcement for that machine. In our setup, we've configured this to be less than 1 second, because higher times the customer will hang up. What then will be done is quite obviously, the core router will start routing the traffic using the alternative route. And because RTP engine 2 is fully aware of this session, it can relay media instantly. So there is actually no hearable impact for the customer. And this is basically it. So to round up, we've extended our architecture with 2 additional data centers which are located in Frankfurt. We have an active redundancy setup running SIP-wise RTP engine on the media relays and controlling it via Kamailio's RTP engine module. We have to tune the interrupt handling on each machine to improve performance. We are synchronizing the RTP engines, the session information among the RTP engines via Redis and using Redis key space notifications for this. And in case of failover or redundancy cases, we are using BGP mechanisms to reroute traffic to alternative machines. So after extending the network, it's now time to extend our team, and you are welcome to visit our jobs offers. If you type VoIP and search for the keyword VoIP, you will find the corresponding opening positions. Thank you.
I will need 1 box from my home. With this, how many millions packets per second? Okay. Just need my cat to get the phone. Okay, yeah, really impressive again, and thanks for sharing all this information. Questions from audience, if someone can still speak. Okay.
Very nice presentation, thank you.
Thank you.
How you do the redundancy on the Kamailio in front?
On the Kamailio front end.
Yeah.
I don't.
Shared IP.
You are referring to if a Kamailio proxy crashes. Is this what I? Right now there is a manual failover to alternative machine using. We have a similar setup, zipgate preset with balance. Audio. Balancers proxies, and if a proxy fails, the balancers will deactivate that one and route it via alternative proxies.
Yeah. So if I'm understanding everything here correctly, you have all the data on the sessions being communicated by the through the database. So what occurs in the case of a database failure?
In case of a database failure, RTP and or let's say you have the situation in mind when Redis becomes unavailable, right?
Yes.
So in this case, RTP engine will continue to work without redundancy, and if the connection comes back, RTP engine will retry to reconnect the Redis and start persisting sessions. So after a reconnection, you need to wait a couple of time until all the media relays are fully synchronized again.
Long time no talk.
Yeah, I can't stop myself. Pavel, brilliant presentation. A couple of very quick questions. Do you do you manipulate the diffserv, the DSCP tags?
Yes, we are setting the type of service bit field. Yes, we are doing that.
It's very useful, isn't it? And it costs you nothing.
It is
Extremely
mandatory.
useful. Well, if you follow the IETF recommendations, but a lot of OTT VoIP people, I said OTT again, don't do that, and they suffer quality.
No, we got a specification from our carriers how to set it correctly so they interpret it in the way we need it.
It's very simple, it's very easy, and it costs nothing.
Right.
But another more interesting question, now that you've got media proxies in line, you can actually get at the media. Does this mean that you have any plans to put into operation applications that handle media?
Right now, not. Right now, we don't have such plans. The next step will be to use these media relays to realize IPv6, IPv4 bridging.
Okay, happy man. And I want to add, until we spot the next question, that if someone wants to look at how they scale in the future the signaling layer, I think at one of the Kamailio awards there was Henning presenting, or at Linux Tag, it should be on kamailio.org/events, and you'll see also a lot of this presentation about the signaling layer. But this was also really impressive and
Okay, thank you, Paul. Thank you, Pavel, for this great presentation. You mentioned the peak packet numbers that you have on the data centers. Can you say something about the peak data rate? How many gigabit per second do you have on the routers in the setup in Frankfurt?
I can't tell you the details about how many the rates. I will maybe operation guys. No, we had to look up. We have to look up.
Yeah, hi. About call quality. So what's the most common issue? Is it packet loss, is it jitter, or is it delay?
The most common issue or the bottleneck in this setup is the subscriber line and the subscriber line and the access network. So very close to the customer. In the IP core of the customers, there is usually enough resources to relay the packets, and there is no need to drop packets or delay them. But at the end line, subscriber line, network, transport network, there most of the issues are packet loss. So due to in favor of other traffic, SIP UDP traffic is just dropped. Or delayed, yeah. But this or the other one is negatively influences the quality of the call.
Okay, so I think we can keep asking for 2 there is a lot of question about this, and they are here again. Probably 1&1 team is the largest representation of a company, 6 or 7 around here. Again, big thank you for the entire team that they support the project with a lot of code across the past even more than 10 years, I guess. Thank you, Pavel, and really impressive.